Okay, here is your test review. First set of directions says to list the first 5 terms in each sequence. This is given to me as a recursive sequence, so I know what my first term is. It tells me A1 is -4. Then this means that each of the next terms, so to get term 2, I'm going to take the first one, which is -4, multiply it by -3. That'll give me a positive 12 plus 7 is 19. Then I have to take 19, multiply it by a -3, add 7, that gives me -50. Take -50 times -3 and add 7, and I get 157. And then 157 times a -3 plus 7 will give me -464. There are my first 5 terms. Okay, so this next one is not a recursive sequence. Instead, to get the first term, I substitute in 1, so 1 cubed minus 2 times 1 plus 2 squared. That's going to give me -8. Then for the second term, I substitute in 2. 2 cubed is 8. And this will be 2 times 2, which is 4, plus 1 is 5 squared. So it'll be 8 minus 25, which is a -17. Then I substitute in 3 to the ends. That should give you -22. You substitute in 4, you get -17. Substitute in 5, and you should get 4. There are your first 5 terms in each one of those. All right, so on these next ones, I'm going to determine whether the sequence is arithmetic, geometric, or neither. So if you can look at it and know that it's being multiplied by something or something is being added, that is an easy way to do it. If you have to check for common difference or common ratio, then you're going to have to do some subtracting or dividing. But if I just look at number 5 here, got 5 to 5/6 and then 5/36. So it looks like each one of these is being multiplied by 1/6, which means that my R would be 1/6, and this would make it a geometric sequence. Remember, if it's being multiplied by something, it's geometric. If something is being added, it's arithmetic. All right, so then I'm going to look at number 6. Well, on number 6, I know it's not arithmetic because I can't add something consistently and the signs flip back and forth. So for the signs to change back and forth, I'd have to be multiplying by a negative number. But if you do the ratio, if you take 16 over 1, or -16 over 1 is going to give you a -16. You take 81 and divide it by 16, you're not going to get -16. So you're not getting anything consistent for the ratio, and there's not anything for the common difference, so this one is neither. Okay, so when I look at number 7, I can see that I've got a -16 to -9, then -2, so I'm adding 7 each time. But remember, if you can't tell by looking and you have to check, then you're going to take -9 minus a -16, -2 minus 9, and see if you have something that's common. Or if it's geometric, you're going to take 5/6 and divide it by 5, and then 5/36 and divide it by 5/6 to see if you have a common ratio or a common difference. But I do have a common difference here. It is 7. That makes this arithmetic. All right, so now we are asked to write an explicit and a recursive formula to find the nth term of each sequence. Okay, so I first have to determine if it is arithmetic or geometric. So if I've got -7, then -14, -28. So let's see, I could say that I'm subtracting 7, but I subtract 7 again, and I don't get that. But if I multiply this by 2, multiply by 2, multiply by 2. So I can say it's geometric then, which means that my R is going to be 2, because I'm multiplying by 2 each time. I also need a 1, which is -7. Okay, my equal sign's too close there. Equals -7. There you go. So since it is geometric, this is where I'm going to use this a sub n equals a sub 1 times r to the n minus 1 power. So a sub n is equal to -7 times 2 to the n minus 1 power. So there's my explicit. A sub n equals negative 7 times 2 to the n minus 1. Recursive, remember you have to identify at least A1, sometimes A2, but A1 will be enough here. So A1 is equal to negative 7. And then if the next term is 2 times the term before it, then A sub n is going to be equal to 2 times A sub n minus 1. And that works when n is greater than or equal to 2. That's because I identified what 1 is, so I have to start with 2 in my sequence there. All right, so let's look at this next one. Looks like I am subtracting 5, and then subtracting 5, and then subtracting 5. So that means this one's going to be arithmetic. The common difference is negative 5. A1 is equal to 8. Okay, so it's asking me for this sequence. It's arithmetic. So I'm going to use the formula that is A sub n equals d times n minus 1 plus A sub 1. So A sub n is equal to d, which is negative 5, times n minus 1 plus 8. So A sub n is equal to negative 5n plus 5 plus 8. So A sub n is equal to negative 5n plus 13. So that's what I get here. So then my recursive, again, I have to identify A1. It's 8. Then, since what is changing here is I'm subtracting 5 each time, then A sub n is equal to A sub n minus 1 minus 5 when n is greater than or equal to 2. Okay, number 12. We're going to write a rule for each sequence, then find the indicated term. Okay, so remember it's sequence. Make sure you're paying attention to sequence versus series. So I have to, again, identify whether it is arithmetic or geometric so I know where to go with this. If I look at this, I am adding 9 each time, right? So that means that there's a common difference, which is 9. It's arithmetic. A sub 1 is 24. So I substituted into A sub n is equal to d, which is 9, times n minus 1 plus A1, which is 24. So A sub n is equal to 9n minus 9 plus 24. So A sub n is equal to 9n plus 15. So there's my rule. Then I'm also supposed to find A19. So that's going to equal 9 times 19 plus 15. So A19 is equal to 186. Okay, number 13. We have to figure out again if it is arithmetic or geometric. So if I take negative 6.9 minus a negative 4.3, give me a negative 2.6. Negative 9.5 minus a negative 6.9 also gives me a negative 2.6, which means I have a common difference of negative 2.6. A1 is negative 4.3. We use this same formula, so AN is equal to negative 2.6 times n minus 1 plus a negative 4.3, or it could have been minus 4.3. So AN is equal to negative 2.6 plus 2, oh, dang it, negative 2.6n plus 2.6 minus 4.3. So AN is equal to negative 2.6n minus 1.7. There's my rule. Then I need to find A24, which means it's going to be negative 2.6 times 24 minus 1.7. So A24 is equal to negative 64.1. All right, number 14. So I'm going to look for a common difference here first. Well, I can tell you without actually finding the actual values here that even if I skipped over this, well, this is 0.25 and 1.5. So 1.5 minus 0.25 is not the same as 9 minus 1.5 or 54 minus 9. So clearly not arithmetic. My only option here is that it would be geometric. And so if it's geometric, then that means I got to be multiplying by something each time. Well, 9 times 6 is 54, and 3/2 times 6 is 9. 1/4 times 6 is 3/2. So my common ratio here is 6. A1 is 1/4. This is a geometric sequence, so I have to substitute it into the geometric one, which is AN equals A1, which is 1/4, times R, which is 6, to the n minus 1 power. And there's no cleaning up that's needed there. Then I need to find A10. So A10 is going to equal 1/4 times 6 to the 10 minus 1 power, or to the 9th power. And you get A10 is equal to 2,519,424. Okay. All right, on the back. It says use the information to find the indicated value. So if I am given an A value and a D value, then I know that I am dealing with arithmetic. And I need to find A34. Well, in order for me to find A34, and I have A30 and I have D, I'm going to have to find A1 so I can come up with my rule. So I have to start with this 30 thing, right? So A30 is 213. That's equal to A1, which I don't know. Oh, no, that is not what comes first. Why do I do that every time? It's equals D, which is 8, times n minus 1, well, your n's going to be 30 right now, so it's 30 minus 1 plus A1, which is what I'm looking for. Okay? So 30 minus 1 is 29, so 213 is equal to 29 times 8, which I'll go ahead and do. 29 times 8, which is 232, plus A1. Then I subtract 232 from both sides, and I get that A1 is equal to negative 19. So now that I have that, I can find A34. So A34 that I'm looking for is equal to D, which is 8, times N, which is 34 minus 1, plus A1, or minus 19. So 34 minus 1 is 33, and 33 times 8, so give me A34, is equal to, so I'm going to do 33 times 8 minus 19 gives me 246. Number 17, we are looking for D. I have A1 and I have A23, so I can find D here. AN, or A23, is negative 16. That's equal to D, which I don't know, times N, which will be 23 minus 1, plus A1, which is 28. So I'm going to subtract 28 from both sides. It's going to give me negative 44 is equal to D times 22. So D is equal to negative 2. All right, so now I'm looking for A11. I have A1 and I have A39, so I have to use those to find D. Then once I find D, I can go find A11. So A39 is 752. That's equal to D, which I don't know, times N, which will be 39, minus 1, plus A1, or minus 8. So I'm going to add 8 to both sides. That's going to give me 760. That's equal to D times 38, divide by 38, and I get that D is equal to 20. So now that I have that, I can find A11. So A11 is equal to D, which is 20, times N, which is 11 minus 1, plus A1 or minus 8. So then A11 is equal to 192. All right, number 19. I'm looking for A27. So again, I have A1 and A17, or I have two A's here. I'm going to have to use those to find D before I can do that. So 77, which is A17, is equal to D, which I don't know, times N, which is 17 minus 1, plus A1, which is 13. I'm going to subtract 13 from both sides, and I'm going to get 64 equals D times 16. So D is equal to 4. Now I can find A27. That is equal to D, which is 4, times N, 27, minus 1, plus A1, which is 13. So A27 then is 117. So now I want to use the information to find the indicated value. Here I have A, but I have R. It's not D. Right? So that means that I need to use the geometric sequence, right? So AN, which is A7, is equal to A1, which is 3, times R, which is negative 6, to the 7 minus 1 power, which is the 6th power. You can type that into your calculator and you get A7 is equal to 139,968. All right, so now we're moving on to the series where we're going to be summing things up. So once again, I have to determine whether it is arithmetic or geometric. So if I want to determine that, I can take negative 53 over 10 minus a negative 19 over 5, and then negative 34 over 5 minus negative 53 over 10. And when I do that, I do see that there is a common difference, and my common difference is negative 3/2. Then A1, which I'm also going to need, is negative 19/5. So for the summation of arithmetic, I have to have A1, I have that. I have to have N, which I have, that's 18. But I also have to have AN. So this is N, I need A18 before I can actually find the sum. So that means I have to figure out, I have to use my little formula, which means I take D, which is negative 3/2, times N, which is 18 minus 1, minus 19/5. Once I do that, I get negative 293 over 10. So now I can find the sum. The sum is equal to, make sure you're using for the arithmetic series, I have to put N out front, which is 18, times, then in the numerator it's A1, which is negative 19/5, plus A18, which is negative 293 over 10, all over 2. When you type that in the calculator, be very careful with your negatives and your parentheses and all that good kind of stuff, and you should get S18 is equal to negative 2,979 over 10. All right, so let's look at number 29 then. Got to see if I have a common difference. So I'm going to take negative 135 minus a negative 405. That would mean here I am adding 270. Negative 45 minus a negative 135, I would be adding 90. So clearly not arithmetic because those are not the same. Then when I take the ratios, negative 135 over negative 405, I get 1/3. Negative 45 over negative 135, I get 1/3 again. So the common ratio is 1/3, and this is geometric. A1 is negative 405. And I want a sum. When I use the sum formula for a geometric series, I need A1, which I have, I need R, which I have, and I need N, which I have. So I'm good to go. The sum of the first 7 terms is equal to A1, which is negative 405, times 1 minus R, which is 1/3, to the nth power, that's the 7th power, all over 1 minus 1/3. Again, typing it in the calculator makes it a piece of cake, but you have to type it in to the calculator correctly so that you get S7 is equal to negative 5,465 over 9. Okay. So here, this means summation again. I can tell by looking that it is arithmetic. It's not set up like a geometric. So in order for me to find the sum of the arithmetic, I need n. N here is 14. I need A1, and I need A14, right? So A1 is going to be equal to 11 minus 8 times 1. So that gives me 3. So A1 equals 3. And then A14 is going to be equal to 11 minus 8 times 14. A14 is equal to negative 101. Okay, so I have these 3 pieces, which I need for the arithmetic. So I get the sum of the first 14 terms is equal to 14 times 3 plus the negative 101 or minus 101 over 2. So the sum of the first 14 is negative 686. When I look at 31, clearly this is the geometric, so this is my A1 and this is R, right? So for geometric, what I have to have for the series, I have to have A1. Well, A1 is negative 5. I have to have R, which is 1/2, and I have to have N, which is 7. So S7 equals negative 5 times 1 minus 1/2 to the 7th power, all over 1 minus 1/2. So I get the sum of the first 7 terms to be negative 635 over 64. All right, so 32 is a little bit different because we don't start with 1, right? So your A1 really becomes A2 since that's where you're starting. So let's look at what's happening here. We need N. So it goes from 2 to 9. So remember, to find N, you subtract them and add 1. So 9 minus 2 is 7 plus 1, N equals 8. A sub 1, which I don't really want anymore, I now need that to be A sub 2 because that's where I'm starting. So I have to find that. A sub 2 is going to be equal to 3 times a negative 4 to the 2 minus 1 power. So that's really to the first power there, so this is just going to give me negative 12. So then I substitute it in. The sum of these 8 terms is equal to A1, or the first term, which is really A2, is negative 12 times 1 minus, oh, I also need R that I didn't write down. My R is negative 4, it's right there. 1 minus negative 4 to the nth power, and your N is 8, even though this says 9 up there, to the 8th power, all over 1 minus a negative 4. So that sum of those 8 terms is 157,284. (33) works kind of the same way, but this is arithmetic and not geometric. So for arithmetic, I need the first term and the last term. Well, your first term is A4, right? It's not A1. So A4 is equal to 1/2 times 4 minus 7/6. And that gives you 5/6. I also need A13. That is equal to 1/2 times 13 minus 7/6. That is 16/3. Okay. So I need N. Oh, shoot. I need n. Oh my gosh, I keep changing this color. Why is it the same? There we go. I need n. I know it didn't matter, but that was bothering me. I have to do 13 minus 4, which is 9, plus 1, which gives me 10. The A1 that I need is actually A4, because that's the first term, and it is 5/6. The last term is A13, and that is 16/3. So when I use the arithmetic series, it's the sum of 10 terms, but it's not the first 10 terms. That's equal to n, which is 10, times the first term we're using, which is A4, 5/6, plus an, which is A13, 16/3 over 2. So I get the sum of those 10 terms is 185 over 6. Okay, and number 34 goes from 1 to infinity. So this is an infinite series, so I have to figure out if it is convergent or divergent. And this right here is 7/5. So since 7/5 is greater than 1, then it is divergent, which means there is no sum. And then I sent out a remind on Friday that told you to change this. I don't know how I messed this one up. But this, instead of 4/3, should be 3/4. Okay. So if I do that, then my R here, oh, I should have put that over here. R is equal to 7/5, which is greater than 1. So on this one, R is equal to 3/4, which is less than 1, so it's convergent, which means I use my infinite formula, and that infinite one is the sum is equal to A1 times 1 over 1 minus R. So I know that A1 is 3/2, it's right here, and R is equal to 3/4. So the sum is equal to 3/2 times 1 over 1 minus 3/4. And that's going to give me that the sum converges to 6. Now you have potential to do very, very well on this test. Make sure you know how to do this stuff. I am giving you all of those formulas that are hanging up, but you still have to know how to do it and when to do what. No reason not to make a really good grade on this test.